Good afternoon, my fabulous chemistry students. This is video one of our second unit, Atomic Theory. When we are done with today's video, we will understand how the modern model of the atom has come about over the past 2,500 years. So what is a model anyways? A model is a picture of an idea. It's going to give us information. Think of a graph of data. It's like a pictorial version of the same information so we can see what's going on. It helps us understand things a little clearer. So the model of the atom has evolved over time. So let's define a few things first. The atom is the basic building block of matter. It's not broken down chemically. Check this guy out. How do you say his name? Democritus. Democritus in 450 BC, that's before Christ. He used the term atomos, described as the ultimate or smallest particle of matter. All right, now we're going to jump ahead to 1803, the first known theory of the atom. Dalton came up, considered the founder of atomic theory. He had some postulates, right? All matter is composed of individual particles. Atoms of a given element are identical. This is still true today. We still go with this. From 1803, this is still sound. Compounds are formed by a combination of two or more atoms. This guy's pretty brilliant. 1803. What did he have to work with back then? His theory was called the cannonball theory model. It basically was spherical, like this blue sphere we see on the left, and it was uniform in density. So it was all just one thing, kind of like a marble. Then, towards the end of the century in 1897, Mr. Thomas came around. He used a cathode ray tube with charged electron field to determine that particles were deflected by a negative electrode towards a positive electrode. So this got him thinking, right? Why would that happen? There must be subatomic particles called an electron. And if something goes towards a negative, or towards a positive in this case, and away from a negative, it must have something charge. It's really small and has a negative charge. Discovered the electron. He came up with a model. It was called the plum pudding model. You see the picture to your right? Kind of like plum pudding. You guys haven't had plum pudding, right? Well, yeah. Let's think of a chocolate chip cookie. Yeah, I've had one of those. So you see the orange, that would be the cookie itself, and you see these little negative electrons. Here it's called the plums. We would call them the chocolate chips. That's right. So the pudding would be positive, and of course the electrons would be negative. And he thought that the electrons were embedded right in there. But that makes me think, how could that electron be diverted off in a direction if it was stuck in there? So, okay, along comes Rutherford at the beginning of the next century. This is a very, very famous experiment. You see this picture right here up in the upper left-hand corner? He is bombarding this gold foil. You see it's yellow. It's thin with alpha particles. And you see all those red arrows? Some are bouncing back, some are going through, and some are going through but moving at an angle. This is a breakthrough in what we call atomic theory. So, Rutherford conducted the gold foil experiment where he bombarded this thin piece of gold foil with a positive stream of alpha particles. He expected virtually all the alpha particles to pass straight through, but they didn't. The ones that bounced back, why did they bounce back? So the nuclear theory changed and evolved. So now the atom, he determined, is mostly empty space. Because look, most of those red beams go through. So they went through. It's metal. They went through. But the center of the atom must be dense and positive because it took those positive particles and bounced them back. Positive magnets going together, right? They repel, right? So he called this positive dense center the nucleus. We've heard this word before when we did cells in living environment, right? Nucleus, that middle piece. All right, on to Niels Bohr, 1913. the famous Bohr model, which we will get into later in the unit, or the planetary model. He discovered that electrons travel around the nucleus in these well-defined paths called orbitals, okay? Just like the planets. The electrons are in different orbitals, possess different amounts of energy. Different orbitals. If they're in different orbitals, they have different amounts of energy. Absorbing or gaining a certain amount of energy causes electrons to jump, just like Mexican jumping beans, kind of, right? To a higher energy level or an excited state. When they are excited, electrons emit or lose that same amount of energy that we gave them, the energy comes off in the form of light. They fall back to the ground state. I'm going to give them energy. They jump up. They come back the same amount of energy, and light is given off. And we're going to find later in the unit that we can use that principle as a fingerprint, if you will. Where we are currently, wave mechanical model. Electrons have distinct amounts of energy in areas called orbitals. An orbital is the area of high probability for where an electron will be found. Do you see the picture? See how it's kind of scattered? Because now the theory is more of it's a cloud. It's a space. Somewhere in this space, you're going to find an electron. Okay? Developed after the famous discovery, both waves and particles act the same. You guys ever think of grabbing and working out, right? You grab those two ropes and you start up and down and up and down and up and down with either arm, and you see the wave flow. Well, that was the theory here, that waves and particles can act the same. Many sciences have contributed to this theory since, and it's still ongoing. On to practice problems. I want you to take everything we just learned from those, go through, answer these questions the best you can, and we will go over them as soon as we get to class. Now, we know where we are at as far as the model goes and how we got there. The most important of them all, guys, is Rutherford. Make sure you pay special attention to Rutherford and that gold foil experiment. I'll see you guys tomorrow in class.